rolling now.
Cool.
Which one are we on?
We're on demonstration problem on page 1009 for chapter 24, capital budgets and investment analysis. So White Company can invest in one of two projects, TD1 or TD2. Each problem requires an initial investment of $250, and it produces the end of year cash flows as shown. So cash flows for TD1 and TD2. Compute the payback period for both projects. Which project has the shortest payback period? So to compute payback period, we have a first cash flow, and a second, third, fourth, and so on, right?
Right.
Our first would be the initial investment of the $101,250 because that's our output for the machine. Correct? Both projects, regardless, are the same thing. Same output. We use the brackets because we're accounting, not math. So we're asking for the payback period.
Yeah, that's what we're putting in.
Yeah, exactly. They're asking for the payback period for either project. It's the same thing. So, say payback period is when do we hit zero and start making a surplus of income, right?
Right.
So, this one's first year is $20,000 cash flow income, right? This one has $40,000.
And that's given in the book, correct?
Yes, exactly. We have our charts here. This year is $30,000. This year is $40,000.
Gotcha.
Right? So by just looking at it alone, these plus these, 50,000, we're about halfway paid off, right?
Right.
So we gotta pay another one, right? So 70,000, right? This one again is 40,000. This, as you see, these are going to be even cash flows, and these are odd cash flows.
Right.
Right. So if we had even cash flows, we could just simply, if we have this one, for instance, this is really simply calculable by our total income over initial annual cash flows. This is if you have even cash flows, which we have here, right?
All right.
And let me go back to the solution. If we have even cash flows, we can simply use this to find our payback period, which is the cost of the investment, which is our $101,250, right? Over annual cash flows, our annual net cash flow, and since they're even, 40,000 each year. It's pretty easy to calculate that.
Right.
So let me put that into perspective for TD2. So the income, was it income? Sorry. I'm screwing up the table.
That's right.
Cost of the investment, 101,250 divided by the first annual net cash flow, right? Because these are all even. This is the even perspective. Alright.
Can you tilt that a little bit? So there you go.
Yep. Right? So and you can theoretically look at it like this too.
Right.
If it's going to say 2.53 years, is when we're going to hit zero and start making a surplus. In 2.53 years, we're going to pay off this whole $101,250 and start making, and that's when we pay it off completely, and then we start making the income.
Okay.
That's with even cash flows. And you look at it like this, like year 0, 1, year 2. About 2.5 years in, you cover your loss.
Right.
So 2.53, that's what you're going to get for that, right? So this is a little bit trickier because these cash flows don't come in evenly. They don't come in like 40,000, 40,000, 40,000. You have like sparsely 20, 30, and 70. So this is going to, you can't really do this equation. You can if you want, but you have to find the annual cash flow. And the annual cash flow aren't even, so you have to find when to a payback period within that region. So what I did was, or for me to help understand this, we have our negative $101,000 and $250, right? And slowly we start paying into it. So after year 2, obviously we still owe over what, $51,000 still after year 2. So we know we're gonna go into year 3 a little bit, right? So
it's 60 and some change.
It's 60 and some change, yeah, exactly. Or technically 50 and some change because it's 101 250.
Right.
So how can we calculate that? I say it like this: here's a bucket. So every year we're putting more into that bucket. This originally was 102.50, right? Every year. So year one we put 20,000, right? There it is a little bit. Year two we put 30,000. Still almost there, right?
Yeah.
So that means we have a deficit. So we put 50,000 in so far. 101, 250. Subtract them. That means we still need $51,250 to fill up the rest of the bucket, right?
Right.
So we need to find out the differences. We need to find the percentage of how many months or how much of the third year gets paid into the continuous cash flow, right? Or through the cash flow. So we need to know 70,000 of this, 5,100, 250 of the 70,000 needs to be paid off, right? So what I do is this 0.73 of this of year three, or since technically this is 1 year, right? What we need to pay out of. So technically, look at it. This is 1 year. This is the full year, and this is the percentage of that full year that needs to be put into it to fill up the rest of the bucket. So that equals 0.73, and then we know already 2 years have passed by. So 2.73. Correct?
Right.
To get our deficit from 101,000 all the way up to paid off and then go start to surplus, right? So let's check our answer. Okay. Cool.
Where are you looking at? Can you point at it so I can zoom in on it?
So TD1, for that year, 2.53 rounded. So it was easily, right?
Yeah.
101, which was our cost of income, our cost of investment. Net cash flow, 40. This means the company expected to recover its investment of TD2 in 3 years, right? So on and so forth, right? So for TD2, let's see what it is. Cumulative net cash flow for the project TD1 changes from negative to positive in year 3, right? So we know after 1, 2, 3, we know in the third year, right? We had to pay in the third year, somewhere in between the third year. We had to pay into it, right?
Yeah.
So as you can see, so change the negative to positive in 3 years. As much as I receive continuously, which in this and this and this. So I just want to show you comparatively. So 70,000 minus what we needed to pay the rest out of was what? 51,250, right?
Yeah.
They give us 18,750. This helps us find the percentage. So we know that we had to pay 51,000 left out of that 70,000, right?
Right.
So, or excuse me. So this is year 3. We still need to pay in year 3 51,250 to fill up the rest of the bucket. So what's the difference between these two? It's 18,750. That's what we have left of year 3, right? This is income.
Right. That's the remainder after we've paid it back.
Yes.
Correct.
Yes. So year 3. Our cash flow got eaten in, this debt ate into this cash flow, right? By 51,250, and we're left with 18,750. To find what percentage of that year 3 had to go into that, we take our remainder that was like surplus income, right? And we divide it by the 70,000 for a specific percentage.
Right.
Right. So divide by 70,000. 0.27, right? So 0.27 was what
In the second year.
exactly in the third year specifically. Right? So 2 years, because 2.27.
Right.
So this is our payback period for this, and this is our payback period for this. It's a little convoluted because the way the book shows it is a little weird comparatively. Where realistically you have to just think. These are investments. How long is it going to take for this investment to break even and then go up?
Now, I don't want to like say this, but like if you can do 3 minus a 2.53, you should get that 2.27, right? Because it's the full 3 years.
Exactly. So what I did was, I earlier calculated a 0.73, right?
Right.
Imagine this is the whole number of what's being invested back into it, right?
Right.
So from that whole number, you can extrapolate to 0.27,
Right.
and then 2 years.
Gotcha. Okay.
A little convoluted, but I'm trying.
But it's good though. It makes sense. So is that the end of the problem?
He did not take the other problem.
Okay. Yeah, thanks.
Let's continue. So
This lighting's all creepy, dude. It's like shadows and shit.
okay, so assume the company requires a 10% return on the investment. Compute the NPV of each project, right? We now know. Excuse me. We need to find the NPV for each project, and how we find NPV. We use our calculator. At the same rate, you want to make sure to also look into your cash flows. They give us our net cash flows for each year.
Right.
Correct. So let's find the NPV for the first one. Right. So our cash flow, the initial investment of our CFO is 0. Our cash flow 0 is the initial investment of 101,250. Remember, it's a negative because you have to negate that problem, right? Let's go down. Our first cash flow here is 20,000. Right. Next cash flow 30,000. Right. And the third cash flow is 70,000. Correct? So now we want to calculate NPV, or the net present value of all these cash flows, okay? So, boom. And they want to set a 10% return from the investment. Right? Go down and compute. We have a negative 5,682 net present value. See, this is going to be slightly off because they're using the chart method, as you can see. But ballparking for our first TD, that's pretty close.
Yeah, what was ours?
5,682, and this one's 685. The reason why is because this one rounds up with specific present value charts. So, depending on what you want to do, it depends up to you. So let's go down to the TD2, project TD2. Let's go back to our cash flows, clear it. We knew we were original, same project, right? 101,250. First income cash flow is 40,000. The next one is 40,000 as well. And the last one is 40,000 as well. Okay. Let's calculate that NPV, and it says the exact same thing as.
All right. So
Continuing.
what did you just say?
So we have our even cash flows 40, 40, 40, 40, or 40 for each year.
Right.
So now we're doing is we entered it in our cash flows for TD2. Now we need to find the NPV with a discount rate of 10%.
Right.
Or return on that investment of 10%. So we got our net. We already. Let me go show you. Scroll up. 10% already for the interest.
Right.
Now compute for the NPV. Negative 1,775.9. So this is also a negative. Again, since they're using their charts, we're gonna have slightly different numbers because they're rounding up comparative to us when we're giving direct, precise answers. Remember, brackets are always negative. 1,775, 1,778, well, 76. A $2 difference, but ballpark. Remember materiality from accounting 1?
Okay.
Numbers within reason, we're good.
Okay.
Draw in your answers to part 1 and 2. Determine which project, if, should be chosen. So what did we have a bigger loss in? So the net present value of cash flows, we have to look at both of them. Which one has a lesser? What would be more appropriate?
Well, this one is smaller. This is a smaller loss than 5,000.
Exactly. So will we take that automatically?
No, but I mean that is one thing to consider, right?
Yeah, but regardless of the negatives, would we even touch these projects? Don't think too hard.
Well,
would you touch a project like this?
I'm trying to look at it and then see what. I would say no.
Yeah, these projects we wouldn't touch them, either one, because they were both coming out with net present value of the cash flows taken into account. We're both coming out negative.
Right.
Because remember, we have to remember the time value of money. That's what net present value has something to do with. Yeah, we're making money in a few years, but how much is that money worth now? Negative.
Right, negative money.
It's not worth it. So what do we say? should not invest in either project. Both are expected to yield a negative net present value and should invest only in positive net present value projects. Although the company expects to recover its investment from both projects before the end of these projects' useful life, projects are not acceptable after considering the time value of money, like I just said earlier. The difference between that brings me to the part with payback period and break even. There are two ways of analyzing projects: capital investments, correct? But you have to also look into time value money versus non-time value money. Payback period is not accounting for how much money is worth now, but with break even, it's taking into account time value of money, how much money is worth now.
Gotcha.
So that's your analysis for either or.
Okay.
Computed the internal rate of return for project 2D2. Based on its internal rate of return, should project 2D2 be chosen? So, let me go to my cheat sheet. Okay. So for our accounting rate of return, it's a project's projected after-tax income over average amount invested in it. And your average amount, if straight line is used, can be to find like how much is invested in the project. You can find that by your beginning book value plus your ending book value divided by 2. If there's no salvage value. If there is a salvage value, you would just do beginning book value plus salvage divided by 2. This is just for your average amount invested into the project, right? Which is the 101,250.
Right.
So let me just show you. We have our amount invested, right? So to compute the project to do internal IRR, oh, this is IRR, excuse me, I thought that was ARR. Regardless, to compute our project TD2's internal rate of return, we first compute the compute our present value as follows. So our amount invested, right, which is the first of the cash flows, right? Net cash flow, right?
First year, right?
Net cash flow for first year. Let me see. For you, this net cash flows for the TD2. As you can see. 40,000 each one. If they ask for total cash flow, this should be total cash flow. But net cash flow is net per year. Okay. So 40,000. So our initial amount invested in the project divided by the net cash flow of 40,000 net per year. It should be saying per year, but net per year cash flow is 40,000. Gives us 2.55 per 1. So the project should. Why do we choose to find anything in this out, right? So we search table B3 for the discount rate that corresponds to the present value of 2.5313 for the 3 periods. From table B3, this discount rate is 9%. So again, your theory of going back to your charts can help you in this, but on the test, I believe we're not going to even be touching upon this.
Right.
I don't think he's going to give us charts at all. So I think finding out these net present values, we're going to have to find out some other way.
Yeah.
So I'm thinking we might use the calculator to find NPV of a specific rate.
Yeah.
You know?
I might ask them for it on Monday. Like, hey, can I get the charts just so I have them? Like, you know what I mean? Just so I have something to reference.
Yeah, exactly. Something to go back to. So, but regardless, that's how we've computed. We just totally computed payback period for both projects. We computed our NPV for each project, right? And we also we decided which project we would invest in and which we would not. We both concluded we wouldn't touch either of them. And the IRR is just here: amount invested, total amount invested divided by net cash flows, and net cash flow for TD2 is 40,000 each year. Remember, net always means not necessarily total, but net cash flow is a net per year.
Right.
Cool.
Okay.
And that's chapter 24.